Alright guys, here's the first of two promised videos from the test review for exam 1. This deals in a face-centered cubic crystal structure, and let's start out by finding the key information that the problem gives us. 1, the type of crystal is directly given, it's face-centered. 2, we're given a density value. The density of the crystal is 21.5 grams per centimeter cubed. So we will use that density later in the problem. And we are looking for the radius. So r equals question mark. That's what we're shooting for. So likely we're going to have to find edge length to make our way to the radius. So next up, we're going to have to find the number of atoms in the crystal. And this is going to require us to know the type of crystal. So because this is a face-centered cubic crystal, then we have 6 faces, and each face of a crystal represents half of an atom. 6 times 1/2. We've got 8 corners. Each corner represents an eighth of an atom. So 6 times 1/2 is 3. 8 times an eighth is 1. Add up 3 and 1. We get 4 total atoms that are in our crystal structure. Okay, next up is to find the mass in the unit cell. So we have 4 atoms. And this is not just 4 atoms, it's 4 atoms of platinum. Now we can take this to moles because we know that there are 6.022 times 10 to the 23rd platinum atoms for every 1 mole of platinum. So, platinum atoms are going to cancel out, and right now we're sitting at moles, but we can take this a step further to find mass by using the atomic mass off the periodic table for platinum, and that is 195.1 grams for every 1 mole. So we want moles to cancel, so for every 1 mole of platinum, 195.1 grams. So moles of platinum cancel, we're left with grams, and that's going to take the 4 multiplying by 1 over Avogadro's number, and then multiplying by 195.1, and that gives us 1.296 times 10 to the minus 21st grams of platinum. Now, for this problem, I now know the grams, and I was also given the density early on in the problem. So just taking note of what we have available, D equals M over V. I know D given. I just solved for M, so now I can use this equation to find my volume. So my density given in the problem as 21.5 grams per centimeter cubed. Now that's equal to the mass that I just found, which is 1.296 times 10 to the minus 21st grams of platinum divided by my volume of platinum. Now rearranging to solve for V gives me V equal to 6.03 times 10 to the minus 23rd centimeters cubed. Now remember, all we've got here is a perfect cube. And if I have a cube, we have the relationship for volume. Volume is going to equal the edge length, which is A, cubed. Or in other words, length times the width times the height. But because these all represent the same length, and that's A, we get V equals A cubed. So I know the volume and I need to find A. The volume we just found as 6.03 times 10 to the minus 23rd centimeters cubed. And that's equal to V. Now V is equal to A cubed. So if I want to get to the A, I need to take V to the 1/3 power. That cancels out this 3 exponent. and that's going to be 6.03 times 10 to the negative 23rd to the 1/3 power. That's going to equal our value for A, edge length. And this works out to, let's see, 3.92 times 10 to the minus 8th centimeters. But when we're talking in terms of crystal structures, more practical to work on a length scale of the picometer. So let's go ahead and convert. I'm going to put 100 centimeters in the bottom and 1 times 10 to the positive 12th picometers in the top, leaving centimeters to cancel out. So 3.92 times 10 to the minus 8th, multiply by 1 times 10 to the 12th, and divide by 100 gives us our value of edge length, or A, in terms of picometers, as 392 picometers. So, now we've got A. And because we know this is a face-centered cubic cell, we've got an equation on our equations page to work with. 8r squared equals a squared. So in this equation, I know the A. What I need to find is the r. So to get A by itself, we're looking at A equal to, well, excuse me, we're trying to get r by itself, so back that up. If we want r by itself, r is going to equal the square root of 1/8 a squared. So that's going to be the square root of 1/8 times 392 picometers squared. And tapping that into the calculator, we get 138.6 picometers, which is going to round up to 139 picometers for the radius, or R value, for a crystal. So, backing it up, just to look at where we went, we had atoms that we had in the crystal structure. We went to moles and then grams that were in the crystal structure. We used the density to find volume. We used volume to find A, and then we used A to find R. So lengthy problem, but it's doable. You'll be given all the equations. You just need to focus on applying them.